Hello everyone, today we are going to determine the area of a regular polygon. This is the second part. I will put the link of the first and the third part in the description box below. So this is a different case because the line that we know here is from the center all the way to the middle of the side of this regular polygon, and the length of this is 14. So how do we find the area of this polygon? So it's pretty much the same thing as the first part. We are going to determine the area of a triangle, and from there we can determine the area of the whole polygon. Okay, so please remember that there was another video that talks about the sum of the interior angle of a polygon, which has a formula of 180 times n minus 2. I will put the link of the video in the description box below, and we are going to use that in the first step. So the first step is to find for the sum of the interior angle of a polygon. So that is the sum of the interior angle of a polygon is 180 times n minus 2. So n here represents the number of sides. So that would be 180. And then we count the number of sides here. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a nonagon. So that is 9 minus 2 is 7. So 180 times 7 is 1,260. So the sum of all the measures of this regular polygon is 1,260 degrees. What does it mean? Since this is a regular polygon, we have an equiangular. Equiangular means all of the angles are equal. So we need to determine what is the measure of each angle if they're all equal. And if the sum of all of this red angle is 1,260, so what is the measure for each one? So then we can we can divide this 1,260 by 9, since there are 9 sides. So I go ahead and write each interior. So each interior angle would be equal to 1,260 divided by 9. So if you divide 1,260 and 9, the answer is 140. So that means each of these corners here is 140 degrees. Again, regular polygon is equiangular. That means all of the angles are equal. So that is 140 for all of these angles. So we're done with the first step. Now we are going to move on to the second step. So just for the second step, we are supposed to draw the, we're going to divide this, this nonagon into equal triangles. So this is like a pizza, and we're like slicing it. So we're slicing this pizza right here into pieces based on the sides. So then since there are since this is a nonagon, we can conclude that there will be 9 pieces from this picture. So there's going to be 9 of them. Now, this time around, we are going to label the parts. So first thing that we need to remember is this whole thing is 140. So this angle is 140. That means one angle is 70 and the other is 70. So since it was bisected, it was cut in half. So if the whole thing is 140, so that's 70 and 70. So that means this side right here is also, it's the same for all of these. So this is 70 and this is 70, and then this is 70 and 70. So all the rest of them, since the total is 140. So from here, we are interested in this triangle right here. So that means this angle right here is 70 degrees. And this angle is 70 degrees. So we will cut one of these triangles here. We're going to blow it up. We're going to make it really big so we can see what's going on. So I will bring this green triangle up here. I'll make it big so we can see what's going on with this piece. So we're taking one piece. If this were a pizza, I'm taking one piece of that, a nonagonal pizza. So we are going to draw the height here. So this was the height. The height was given. In our problem, it was 14. So this measure right here is 14. And then we determined the measures already. Since the whole thing is 140, half and half would be, this is gonna be 70 degrees. And since this is the height, this is a right triangle. So then we are interested to, again, this is 14 right here. So I'm just gonna move that over here. So we are interested only with half of this triangle. So I will take half of this triangle and bring it up here, and we are going to find the area of this half triangle. So if we can get the area of this half triangle, we can determine the area of the polygon. So in here, I can label this as 14. So this is 14 right here. That's the height. And then this one right here is 70 degrees. And then this side right here is actually our height. So I'm going to label this as the height. And this side right here is the base. Now, let's look at what is height and base in terms of adjacent, opposite, or hypotenuse. So this is our hypotenuse here. If this is angle 70, so the height here is actually our opposite, since that is across the 70. And the base here is the adjacent. To find for the area of this small piece of triangle, we are supposed to use this formula, base times height divided by 2. We already have the height, so we already got that. But we don't have the base, so we're supposed to solve for the base. So this is adjacent and opposite. So then we are going to use the TOA, opposite over adjacent. So let's set that up. So that would be tangent of 70 equals opposite. So the opposite is the height, which is 14, over the adjacent is the base, and that is missing. We don't know what it is. So we remember that there is an invisible denominator of 1. And then from here, we can cross multiply these fractions here. So that would give us base times, so that's going to be base times tangent 70. So I pair them up. So that is tangent 70 equals 14. So 14 times 1 is just 14. So if I want the base, because I already have the height, but I don't have the base. So then I go ahead and divide both sides by tangent 70. So I divide this by tangent 70, divide this by tangent 70. And then I'm going to use calculator for this. Just a reminder, be sure that your calculator is set in degrees. The answer that we have, if we divide 14 divided by tangent 70, is 5.10. I rounded it off. Now, if you don't get 5.10 with your calculator, it means that your calculator is not in degrees. It can be in radian. So that is the base, 5.10. So then I can go ahead and plug it in here. I already have the base for this triangle. I already have the height. So I plugged it in. So that would be 5.10 times the height is 14 divided by 2. So then if I multiply these two and divide it by 2, that would be a 35.7. So this is the area of this little triangle right here. So the area for that little triangle again is 35.7. So the area here is 35.7. That's half of the triangle. So to find the total area here, we're going to use this formula right here. So that would be the area that we got in step 4, which is 35.7 times the n. That means the number of sides. So we have 9. And then multiply it by 2. Again, others are going to ask, why do we have to multiply that by 2? Because remember, this one is just half. This 35.7 is just half of the triangle. And for every n, for every side length, which is n, there are 2 of them. So 2 of them. So we're going to multiply 2. That means there's only, if you don't multiply this by 2, that we're getting the area of half of this only, since 35.7 is just half of this green triangle. So we have to multiply it by 2. So then the final answer that we have here is, if you multiply these 3 numbers right here, this would be 642.6 is our total area. So that means this is the area of the whole polygon. If you find this video helpful, hit like and subscribe for more math videos. See ya!